So we're back, and I'm really excited about this next talk. Netflix is always setting examples for all of us to follow, and it's always really a pleasure and a treat to listen to the example that they're setting. So today we get to hear from Paul Backer about testing the ways Netflix does. So
Thank you. It's going to be a little hard to follow up the previous talk, obviously, so that pleasure is all mine. We're going to talk about testing, and specifically how we use testing or how we are testing our Spring Boot apps at Netflix. That's not just a catchy title, although it is a little bit. This has actually been a lot of my work this year to kind of move our testing strategies forward at Netflix. So this is something that we are very actively working on and using. Now, although it is how we do things at Netflix, all the tools and the code that we are using is all just open source Spring and Testcontainers and things like that. So there's nothing Netflix specific about it. This is just how we use those existing things, and you can do exactly the same thing. My name is Paul. I'm in Java platform at Netflix. I'm also a Java champion, and if you were at my talk about GraphQL yesterday, I'm one of the authors of the DGS framework. The photo is just outside of Las Vegas, little bit of a different scene, which is only 30 minutes from here. And let's dive into it. So pretty much everything we're going to do today is going to be in the IDE, and we're going to walk through an application and see how you would actually test that and what kind of options you have with the different pros and cons of those options to test real code. But the one thing that I want to point out is that if you look at our testing flow at Netflix, all the way from writing code to production, there's many things going on. And we are going to focus on what I call the inner dev loop. That is kind of, I'm writing code, I'm running my tests, maybe I'm running the same test in CI. That's what we're talking about today. After your build finishes and you run all your tests in CI, many more things can happen. You can have end-to-end testing, you can have canaries, all the things that make sure that you didn't mess up and you don't cause an outage, basically. Those things are very interesting, but kind of outside of the scope of today. Today we're focusing on how do you actually write your tests and how do you use Spring Boot for that. So that's what we get into. And as I said, we're just going to look at a demo, and this is of course an AI-generated image, very appropriate after the last talk. And the application that we're going to look at, this is kind of a super simple diagram. I'm going to have an application that is kind of our LOLOMO. So our list of movies, as you're maybe familiar with if you're a Netflix user. And this is a GraphQL app, but don't worry, you don't need to know GraphQL to understand this. It's a GraphQL app, and we are basically sending a GraphQL query top 10 to the service, and it goes through the whole web stack like normal. There's a GraphQL schema, and then I have my data fetcher code that kind of lives in the framework. But then there's a whole bunch of other components going on there as well. I've got a Spring Data JPA repository sitting on top of Postgres, so there's a bunch of SQL going on. I've got a top 10 component with a bunch of business logic. And the top 10 component is actually calling out to OpenAI to generate a list of top 10 for a given country. That's not how it actually works, but I thought it would be kind of a fun thing to introduce. And it is also fun to introduce because it adds latency to our system. Now suddenly we have this other system outside of our laptop basically involved, and that adds latency because OpenAI is really, really slow. So that's not good for my test. It also cost me money. Every time I do a call, they charge me for it. So we have to deal with that scenario in our test. So a few complexities, right? We have a GraphQL framework. We have OpenAI as an external component. We have a database. How do we test all that stuff? And that's kind of what we're going to look at. So let's switch to IntelliJ. And since it's a GraphQL application, of course, we have a schema. This is my GraphQL schema, and we are going to look at those two methods which I implemented. So we click through, and this is a DGS component, so this is my GraphQL component. And the first thing I want to look at is there's two dependencies here, a shows repository. A shows repository is a Spring Data JPA repository sitting on top of Postgres. And I used a native query here. This is Postgres-specific SQL. Now you can be like, okay, why would I care? Well, you should care because this is actually a problem for your tests. How are you going to do testing if you specifically need Postgres for those tests? We'll get to that. The second component that I have here is my top 10 service. And this is just a add component. But on its turn, it has a OpenAI service dependency. And the way we use that component is that during post-construct, so in initialization, I'm doing prefetching of 2 countries' top 10 lists. And I'm actually doing a call to OpenAI. Let's take a look at the code real quick. That is kind of the same thing as we saw in the previous talk about AI. I'm using Spring AI to talk to OpenAI, and I'm basically telling, well, give me the top 10 of the most popular Netflix shows in a given country. Again, this is not at all how it works in the real world, but it is kind of fun to play with. So I've also made this a post construct so that we now have this extra latency during application startup. My app takes like 10 seconds to start up, and that is not terrible. It's kind of annoying during a test if that's what you have to deal with. So again, it's something we have to look at. And then finally, this data fetcher component, we have 2 methods. Let's start with the simple one. The simple one is shows in category, and we're simply using this find by category method on my repository to talk to SQL or to PostgreSQL, and we get a list of shows. And then a slightly more complex method is this top 10. And I'm doing some checking if the input here is valid, and otherwise I just replace it with a nice default. I'm also throwing this special exception, and I have some exception handling in my code that specifically looks for this exception. And then we just call this top 10 service that we just looked at that potentially calls out to OpenAI. Not that bad. To kind of get an idea how that looks like, if I open my browser, the application is already running. I can do a top 10 query, ask for country code USA. I get a list of shows. If I do the same thing for a country that I didn't pre-initialize, it takes a lot longer because now I'm actually talking to OpenAI. It takes a few seconds, but I do get a nice list. And the other query, the shows in category, is just doing a Postgres call. That's all the application is doing. So how do we test this? Well, this is just a Java class, right? So can we just write a unit test? We can at least try. So let's do that. Let's write a unit test. And this is what I call a pure unit test. And that is kind of 2 things. It means I'm not using any framework features. So there's no Spring, there's no GraphQL, there's nothing. There's just Java. And that also means that I want to test my component in isolation, which means that I have to mock out my top 10 service and shows repository, because I'm just going to test my Lolamo data fetcher. That's the code that we're going to focus on. So I'm using Mockito. You're probably all familiar with this. I'm just using Mockito, create some mocks. And if you look at the actual tests, I have to configure Mockito to say that, well, if this top 10 service is being called with a specific country code, then just give me this hard-coded list of shows, so show 1, 2, and 3. And then we call the data fetcher, so this is the code that we're actually testing. And we can just do an assert to see that we indeed get the shows back that we expected. Not too bad. I do the same thing for the not passing in a country, because I had some special logic here to handle the null case. Pretty straightforward. Same thing for an empty country. And then moving to the shows and categories method. Now I need show entities as mocks, because now I need to get into my kind of my database space. So these are JPA entities. Set up some test data for that as well. And again, I'm just mocking out my shows repository and test that my data fetcher, given those mocks, is giving me the right data. All very straightforward. I think this covers most of our code. So let's take a look. Let's run our tests with coverage. This is a really nice feature in IntelliJ. You get kind of a coverage report like in your code. And once Gradle decides to run the tests, all the tests are green. That's excellent. And if you look at the coverage for our data fetcher here, we see that we almost have 100% code coverage. So actually, let's click into it. And again, IntelliJ makes this really nice. In the gutter here, we see this green bar, and it means that code is fully covered. And then here we see that we have yellow and red. And yellow means I tested only one case of this if statement, and red means it's not tested at all. So I missed this just for demo purposes, but that's fine. We have almost 100% code coverage. Am I ready to go to production? Am I confident that this is actually going to work? Maybe not so much. Because yes, I tested my Java code, but what does the Java code actually mean if we ignore the GraphQL schema and the database and all the annotations? Not so sure about that. And I can prove that. Let's introduce a bug. I'm going to go to my schema and I'm going to make a typo. This is no longer the top 10 query, but the top 101. This is no longer going to match this top 10 method. There's no relationship between them anymore. However, if I run my unit test, the unit tests are just gonna give me, this looks awesome, go to production. I don't think we should go to production right now. And what we can do is, let's start the actual application, or at least try so. And we see it takes a little bit of time because, again, we're doing that initialization with OpenAI, but my application fails to start. And if you look at the exception, it says there's a schema mismatch exception, and the framework actually detected that I have a DGS data annotation on something that doesn't match anything in my schema. So this is a bug. The framework knows this is fully broken, this doesn't work. So the framework is smart enough to figure this out. Apparently my unit tests are not. So unit testing is not really the right solution or the right level of testing for this type of code. This code just doesn't mean anything without the frameworks around it. So what we have seen so far, we have our whole application. My unit test is really just focusing on the data fetcher Java code. And yes, that can be nice to use it that way because it's very easy to use mocks to control like the exact behavior of my dependencies and get into all the corner cases, especially the unhappy pods. But very clearly, this is not enough. This is not okay. So what can we do? We need something different. And we're going to go to the other extreme. We are going from unit test to what I call a smoke test. And a smoke test is basically starting up the whole application and figuring out if that even works. And this is a smoke test that looks very silly, it's empty, but it is actually a smoke test that is required for every application at Netflix. Because what this actually means is that with a Spring Boot test, it will figure out what components exist in my application. It will start up the whole thing the same way as it does as when I just normally start the application. If it successfully starts without any exceptions, test is happy. If my startup fails because of a dependency injection issue, or in this case, a GraphQL validation error, the test should fail. So I still have this bug here. Let's see if we run the smoke test, we will actually detect this bug. Now you will also see that this test takes a little bit longer to run. It should take about 10 seconds because it almost goes through complete startup. It already talks to OpenAI, so there's a lot of cost to running this test. However, we do get a failure, and I'm happy about that. And if we scroll all the way down, we get that same schema mismatch exception, and the framework is saying, well, this application won't start because you clearly have a mismatch. Okay, we have a little bit of coverage from our unit test. We have some coverage from our smoke test. Are we ready to go to production? I don't know. I think we can still break this thing and not detect it in our tests. Let's fix this bug at least. So let's verify that the smoke test is running in the meantime. Let's go. Okay, application starts. If I go back to my data fetcher and I introduce a completely different bug, I forget my DGS component annotation. Now you would think this is a very similar error, but actually from a GraphQL perspective, this is very different. it is okay for GraphQL that I define something in my schema that doesn't have a data fetcher. I can return partial data. I can return null as a valid response to data. And that's exactly what's going to happen here. So if I test my application by just running it, we'll see that it starts successfully. But if I go to my browser, we get null for all my queries, basically, because there's no Java code that relates to my schema anymore. However, startup is fine, because this is not something that we can detect or should detect at startup. So my smoke test, I should prove that actually, my smoke test is not going to detect this, because it's just checking if startup is fine. Startup is fine, so smoke test is fine. My unit test completely ignores all annotation, so my smoke test is going to be perfectly happy with all this. Yet my application is completely broken because a very trivial issue, right? I commented out an annotation, and this would be pretty bad if I roll it out to production. So what should we do about this? Well, we already have this smoke test. What if we would add like just one request in the smoke test? For this, we really just need to do one GraphQL query, and we know that this application is working or not working. So let's try that out. Let's see if that would be a good solution here. But this is kind of the next level of smoke test. I still have my Spring Boot test, which is still going to bootstrap the whole application. That means it's still slow, it is still expensive, but that's kind of what I want out of a smoke test. But in this case, I'm injecting mock-MVC. And mock-MVC is probably something you've seen before. This is making it very easy to do a HTTP request to my server that runs as part of the test without actually having to open ports and deal with port conflicts and all these things. So what I can do now in my test is I write a GraphQL query, and I use mock-MVC to send that GraphQL query to my GraphQL endpoint using mock-MVC. So it does a HTTP post to /GraphQL. Because it's a GraphQL query, I now have to kind of understand how a GraphQL query actually gets sent to a server. And it means I first of all have to wrap it in a GraphQL request, which has a query field. And then I have to convert it to JSON using Jackson here. And I have to make sure that it's set the correct HTTP headers. It's all not very, it's not hard to do, but this is a little bit more lower level details than I really care about at this point. But let's test it out. Let's test this, run this test. And again, we still have this bug in the code. There's still no DGS component. So this test is again starting up my whole application, and it is failing. And actually the output is quite nice because I get a HTTP 200, which is expected because it's a valid GraphQL query, and it's fine that there's no data for this query. But in the body, we can see that the top 10 query is just null. So clearly, my test is unhappy, and it should be unhappy. Now, you might think, okay, fine. Finally, we have all the pieces together to prove if the application is working or not. But imagine that this is the only test that you have. First of all, we only cover one query, right? So if I would have to cover all the queries in a larger application, writing it in this kind of lower level way is kind of a pain. It's doable and you can write utility methods and all that, but it's kind of a pain. The other problem is that if I'm just looking at the final result of my service, and maybe there's like 20 components involved and a database and an external service call and all these things, and all I know is that, well, the data that I got back wasn't what I expected, where do I start debugging? That becomes difficult, right? If you just look at your system as kind of a black box. But at least we have this thing proving that my application is not ready to go to production. And again, if you have a smoke test for a GraphQL server at Netflix, this is kind of what we recommend writing. At least have one test that goes through the whole flow so that you kind of know that as a black box, it kind of works. So that if you introduce like a really, really bad bug with a dependency or something like that and just things blow up, at least you will catch those. I'll put this back. So far we have now seen unit tests. We've also seen a smoke test, which is kind of a black box. But we have seen that smoke tests, because they are a black box, they have problems. The first problem is the extra complexity of debugging a black box. That is kind of difficult. The other problem that we have seen is that because I'm starting the whole application, there's a lot of cost associated with that. Already in this really simple application, it takes 10 seconds to run this test because it takes 10 seconds to run to bootstrap my application. If you look at Spring Boot applications at Netflix, very often they do all sorts of data initialization during startup. It pre-warms a bunch of caches, it pre-warms IPC connections, and it often takes at least 30 seconds to do a bootstrap. Some applications take multiple minutes to start up. I'm not happy about that, but it is sometimes the reality of like a larger production app. I would be pretty unhappy as a developer if every time I run my test, I have to wait for a minute to run that test. And it's only one test. Now I want to have 300 tests. 300 times 30 seconds, not a great not a great developing experience. Now Spring has a little bit of smarts there. If you look one more time at the smoke test, if you have multiple smoke tests that all have exactly the same setup, there will be context caching going on, and it will actually be reusing the same Spring context and not actually restart. But as soon as I introduce something like a mock bean, that mechanism falls apart. And it does actually have to reinitialize the context. And now you're back at waiting all that time. So only having smoke test is easy to write, but very expensive from a waiting experience. So can we do something in between maybe? And that is kind of where we're going. Now we're getting to the point where I would say that we recommend at Netflix that you should write like 95% of your tests should be written this way. And I have two different examples of this. But this is kind of where we want to go. It is still a Spring Boot test, but notice this classes argument here. While in the previous example, it was just Spring Boot test. If it's just Spring Boot test without classes, it will bootstrap the whole application. It will bootstrap everything it knows about. If I specify classes, that behavior changes significantly because it's only going to bootstrap the components that I explicitly list here. So all we get is a test that bootstraps like core dependency injection and 1, 2, 3, 4 components. That's it. That should be a lot faster than bootstrapping the whole thing. So what do I put here? Well, I want to test my Lolamo data fetcher, so that one needs to be there. My Lolamo data fetcher has a dependency on top 10 service, that one needs to be there. I have a custom exception handler. This is some GraphQL component that does exception handling for my GraphQL component, but it's sitting in a different class. I want that one to be there. And then finally, I have this test configuration. And this test configuration is another Spring testing feature. And we can use that to override beans just for testing purposes. And what I'm doing here is I'm mocking out my OpenAI service, which is that Spring component that actually talks to OpenAI. And I'm mocking it so that it always returns the same list of integers for my top 10. This has several advantages. First of all, this is much faster. I don't actually make a call to OpenAI. So I don't get an overhead of like the 1-2 seconds for every call. It's cheaper because I don't have to pay for a mock call. And third, now I get a reliable list of data basically. So I'm always getting the same data. While if I'm asking if I ask OpenAI, give me a top 10 list, I might get a different answer every single time that I execute it. So it becomes harder to verify my tests. Now this test configuration is tricky to work with. There's all sorts of gotchas in how that actually works, depending on if this is on a top level class versus a inner class. And the behavior is kind of weird. And it will at some point start complaining about, well, you're not allowed to override this bean, it already exists, and it is not great to use. Luckily, in the next version of Spring Framework, we will actually get some better options for creating beans in that override basically the standard one. So that is something that I'm actually looking forward to. So we have our components defined, and I've decided that my shows repository, the thing that sits on top of my database, for now, I'm just going to create a mock. So add mock bean is another Spring feature. It will create basically a Mockito mock for me, and also replace all the instances that would get injected where shows repository would get injected with that mock. Now I have one more thing to solve, because I still want to send a GraphQL query to my service to actually test it and test all my annotations and all that. But for that to work, I need a DGS framework to be part of my framework startup. And for that we use a test slice. And a test slice is a concept that we use all over the place in general in Spring, but also at Netflix. And basically we can use those to enable a specific feature in Spring Framework, or in this case the DGS framework. And you can also easily write those yourself. So if you click into this, we see that this is just an annotation, and there's not a lot going on here. Now sometimes you see just a long list of classes defined here, similar to what we see here. So I could just have a meta annotation that lists, okay, I want to always have these components part of my test. In this case, there's this import auto configuration. And if we look at the library that provides this, there's this meta-inf Spring with imports, and these are the auto configuration classes that will automatically be added to my test anytime I use this test slice. That's kind of conceptually how a test slice works. It's very simple, you can easily create them, just create your own annotation, and we will do so in a moment. So I'm mocking my shows repository still, so I still need test data for that. But other than that, I can now have my test where I'm just configuring the mock for shows repository. So I'm mocking the database, but I'm sending a real GraphQL query using the DGS framework. And that goes through the DGS query executor, and then goes to my data fetcher, and then goes through all the other code that I have made part of this test. And then we can just do any asserts that we want. And let's run this test. The other nice thing is, because now we're bootstrapping a very small part of the application, this runs super quick. This runs as quick as a unit test. And in fact, actually we call these things at Netflix just unit tests, because they are just as fast. They kind of fall into the same category. But of course, a lot more is actually going on. Now, one test that I kind of want to point out here is we have this unsupported country test here. And if you go back to my data fetcher for a moment, I have this hard-coded arbitrary list of supported country codes. So these are the countries I support in my service. And if you pass in a country code that is not explicitly in this list, I'm just arbitrarily throwing a top 10 not available exception. And then I have a GraphQL component which is a controller advice, and that controller advice is explicitly catching this type of exception. That's an exception that I'm throwing. And if it finds that exception, it will make a nicely formatted message for the user, and this is what's being sent back to the user in my GraphQL response. Now, we've already seen this working in a test just now. So let's introduce a bug. I'm going to change this exception here to, let's say, illegal argument exception. So it's no longer catching the exception that I actually want to catch. And if I run my tests again now, that blows up, and we will see that there's a different error message now than the one that I would actually expect. So the nice thing is that we now have a few components working together, and we can actually see the interaction between those components and test things that are not really just the one class. And you wouldn't catch those things with like a pure unit test, but if you put them all together in an application, that is where kind of the magic happens and where also bugs usually come from. We still have something weird going on though, because I've mentioned this Postgres database many times during the talk already. And just now I decided to just mock out this shows repository. But we've not actually tested any of the SQL so far. And I can prove that again by going to the SQL query and just put some bogus there. This is an invalid query right now. If I rerun any of my tests actually, but I'm just rerunning the same test that we just had, guess what? It's all happy because we mocked out a database. Is it a good idea to mock out my database in a SQL? Well, maybe sometimes if I want to test very specific corner cases and I have other tests that cover my SQL. But in this case, it would probably be more useful if my test would actually include the call to the database, because why not? But that brings us to a problem, because how do we run a database? Well, so far on my demo machine, I've cheated a little bit and I had this Postgres Docker container running, and that is why we have a database. Now, there's many problems with this approach. The first problem is that I can't actually run Docker this way on a Jenkins host, at least not on Netflix, because there's like containers and containers and all that sorts of issues. So I can't run this same Docker container when running on CI. Okay, that's a problem. Another problem is that if I'm running this and I'm just reusing the same thing with all my tests, and also I'm using it for my like local testing and development just in the browser, I probably will introduce new data to that database, and the next time I run my tests, the test will fall over because it gets different data. And now I have to figure out, okay, did I break the data? Did I introduce a bug? What is going on? So just reusing an existing database, either in Docker or the real thing, is problematic. It's just not a good solution. So let's stop this container. And by the way, now my smoke test would also fail. So this is something we have to solve for. And the way we're going to solve that is we're going to use Testcontainers. And Testcontainers is something that we also rely on pretty heavily at Netflix for testing. Testcontainers is a Java library that gives you a Java API to basically start Docker containers as part of your test. And the life cycle of those containers will be controlled by your test. So your test will start a Docker container, in this case Postgres, but we also use for things like Kafka and AWS SQS and S3 and many other things. As part of your test, this container will be started. You can insert test data specifically for your test, and then the container will be gone again. Now you might be saying, well, hold on, that sounds great, but didn't you just say that you can't run Docker containers on CI? Well, that is true. However, Testcontainers also comes with a feature that you do have to pay for, but we do, which is Testcontainer Cloud. And with Testcontainers Cloud, the actual Docker containers will be on a remote host in the cloud, obviously, and then there will be port forwarding to and from that container so that your test can actually talk to that thing. That means you don't have to be able to run Docker on the actual host that you're on. It also solves the issue that if I'm on a Mac with Apple Silicon, many of the existing containers for Docker are not optimized for this hardware architecture, and they run super slow compared to running it on a Linux machine, for example. With Testcontainer Cloud, you don't have the problem because it will actually run on the correct host. So what do we have to do to use Testcontainers? Well, not a whole lot, really. It's almost the same test that I have here. I have still my Lolomo Data Fetcher show repository. Oh, that's new actually. Now I do have my show repository. We have top 10 service, and I still mock out OpenAI. I have the DGS framework, and now I have a new annotation here, enable database test. Again, this is a test slice, but this is a test slice that I defined in this application. Now, this is a bit of a mouthful, because I need a whole bunch of annotations to configure Spring Data JPA. But that is why you want to put this on a meta annotation, so that you only write this once for your application, and then all your tests can reuse this. So I enable JPA, I do some entity scanning, I configure Spring Data JPA, I need an entity manager. This one is really important. I explicitly tell it to not start an in-memory database. The default behavior in Spring is that it will start H2, an in-memory database. And that's kind of the traditional approach of testing databases if you don't have test containers. The problem with something like H2 is it is a different SQL dialect than Postgres. And that means that if I go to my shows repository, oh, what did I do? If I go to my shows repository, I'm using a native query here. And this is actually Postgres-specific SQL. So this wouldn't work in an in-memory database because that database has a different SQL dialect. Now the traditional thinking about it is, well, okay, fine, we don't use Postgres-specific SQL. You just have to use like the common SQL dialect. And that's what I've been doing for a long time. And then you get into JPA and it abstracts even further away. But databases are really, really powerful. And when we get now in like even the AI space, Postgres has a lot of functionality specifically for that, but it's not standard SQL. So actually, you do want to use your database to its full extent. And I do want to use this any keyword because it's really useful. So I want to use that during my tests as well. So back to the test. We had this enable database test. So this is all the standard Spring annotations. And then there's one annotation that doesn't import, and this is the test configuration that I created. And this is kind of where the real magic with test containers happens. I have a service connection in Spring, and the service connection returns a PostgreSQL container. Now we're in the API of test containers. And all I need to do is tell it that I want a PostgreSQL container. I can give it my schema. I can give it some test data. And now Spring will replace these properties. These are the properties that are normally in your application.properties or application.yaml. It will replace those properties with whatever value we need to connect to our test container. No matter where this test container is running, if that is on my laptop or actually in Test Containers Cloud. And actually, when I run this, it runs in the cloud. So that's all the code we need to bootstrap Postgres in our test. And given this, we can now run our GraphQL query again. Again, we're just using the DGS framework. There's no HTTP here. There's no web layer because I don't really care about that layer for this particular test. I just want to execute GraphQL. I don't have to mock anything for my database anymore. It's the real thing. And I can also now do more specific asserts on things like show titles because I know exactly what data is in my database. And I know exactly that that's the data that I will get back if it's doing the right thing. Now let's go to this test. This is my test shows in category. Same thing. I'm doing a real GraphQL query. It should go to the real database. But remember, our database is broken because bogus. Let's see what happens. I'm running this test. Let's run both tests actually. And the top 10 should pass. That should be fine because it's not actually using that specific query. But the categories query should fail. Now the first time that this test runs, it is actually now bootstrapping a test container in the cloud. Sometimes it's super fast. This time it's not. If you keep running the same test, it will actually keep that container around and it will be much faster. And as expected, my top 10 is passing, but this test shows in category is failing. And we're getting a JDBC exception and it's saying, well, there is some syntax error near bogus. Well, I think that is indeed a syntax error. So let's get rid of bogus. Run the test again. And with enough patience, both are now passing. So what did we test in this scenario? I chose, and this is a choice, so you have options here. In this case, I made a choice to include my GraphQL schema, my data fetchers, including the DGS framework. I included my JPA repository and a real database. And I excluded OpenAI. And that is the configuration that I came up with because that felt like the right set of things that should work together. Is that the best set or the only set? No, you can have many variations of these things. And that is kind of where the power of Spring Boot test with classes comes in. You can have many different tests that have different configurations of components working together. Maybe some of them are mocked, so you can get into like the finer details of error handling. Some of them are the real components. Sometimes I do want to include my database. Sometimes that is inconvenient. I have all these options, but the important thing is it's really easy to write these tests, and they run really fast. And with Testcontainers included, I can test with like the real components that I actually rely on. So I could shape this a little bit differently, but this is the technique that we basically use for all our tests at Netflix. Now you might be wondering, in Spring we also have these annotations like WebMVC test. And that is actually just the same thing as a Spring Boot test classes with some test slices included. And so it's the same thing. It's the same mechanism. I find that these provided annotations are often a little bit limiting. And often you want like a little bit more and then you have to fall back to Spring Boot test classes with some test slices. But technically they're just the same thing and you can, if they work for you, just use them. They're convenient. But this is really just gives you a lot of flexibility in how you write your tests. Now, what tests should you write? Well, as I said, at Netflix we say that 95% of your tests, and that's kind of just a number that I just made up, but most of your tests should be at Spring Boot test classes, given the test slices that we have. You want at least one smoke test. And if it's a GraphQL or a REST service, you probably should do that one request so that you know that at least things sort of work at a HTTP level. And then maybe you have some unit tests if you have some more complex business logic that doesn't use any framework stuff. It's fine. Unit tests are not bad, just usually not sufficient. So use most of these tests. They're really fast as a unit test, and that is kind of how you can structure things really nicely. That brings us to the end. Thank you very much. I have the code that I just showed and walked through available on GitHub. You can run the test. You can probably not run the application because you need an OpenAI key. If you put that in the properties, then it will just all work and you can happily play around with this thing. You can also find me on Twitter. My Twitter handle is right there, and feel free to ask questions there as well.
Amazing. Thank you so much. What a great presentation. Great to have so much practical advice. Yes, very well deserved applause. Who has questions? Okay.
Thank you. Do you have any process to make sure that the tests are actually getting written and applied in your software? Do you have any governance that goes along with that?
Do we have any governance around testing? That's actually an excellent question because that is something that is actively being worked on like this year at Netflix. All the services are tested, but we are not necessarily always happy about the way they are tested. Often they are slower than they should be or could be. So we are actually in an effort to make tests better, make them faster, educate basically, and also getting more insights in how many tests do you have that are slower than they probably should be. And we're getting all these insights now basically to instruct teams like you probably can do better and this is what you could be doing. So that it's not really governance, it's more giving advice, giving insights.
Any other questions? Any other questions? All right. Well, thank you so much for a fantastic talk.
Thank you.
We're very happy to have you here.
Thanks.
All right. A round of applause for Paul. Thank you.